So we are starting problem session 2. Looks like we might have Mark joining us. Hey, Mark.
Yes. I'm here.
And for those wondering where to get all these things, in case you are still wondering, assignment 2, scroll down, and these are the in-class problems we're doing today. And another extremely important note that this is probably the most important assignment in class. So I want everyone to give it their all and not slack off, that you really got to get this thing squared away, because this is what's going to be, we're going to be doing this for the rest of the semester. A lot of good problems here, and today we're going to be doing 2.5, 2.6, 2.7, and 2.8. And that will give you a good foundation to do the rest of them. That's 4 out of 10 problems you can get done today.
Oh, because B equals IR and that would be, no, 36.
And my other important note is that when you're doing these, it's okay today because you're doing it in class, but when you're doing this at home, you really should have the book open to the example problems that come immediately before the practice problems, because they're extremely similar. And when you read the example problem solution, you'll understand how to solve the practice problems. So that's how engineers work. And going forward, we're not doing any more practice problems after today, but those example problems in the book, you can do the same thing with the actual chapter problems at the end of the chapter. Just look for the example problem that matches it and do a correlation between them until you get the right answer. So, do you have a question?
Yeah, we do. We're getting 9 amps for 2.5, which does not allow the answers to be 12 and -6.
Let me see here. So let me see. So is that the circuit? Let me see your handout. So we've got this circuit here. This is such an awesome thing. Well, it's not focusing at the moment, but that looks good. 10 volts, 4 ohms. You got the minus in the right way. Minus plus V2. Good. Okay. So you did KVL, right? And you propose that there's a current I, or no, you're just using voltages, right? So minus 10 volts plus V1 minus 8 volts minus V2 equals 0. And then you say, well, there's an I circulating around this whole loop, right? It's the same I everywhere, it's just one loop, right? So you drew the I going this way, right? And so you rewrote this thing minus 10 volts. Here the I is going into the plus side, so plus 4I. You got minus 8 volts. And then you did good, you got minus, but that's actually the issue. So this is a perplexing thing that you're going to run into from time to time, right? What is the high energy side of the resistor? Is it this side, or is it this side? The way you've drawn I, and again, if you're going to use, so this is an active sign configuration. There's a couple ways of looking at this thing, right? You've got the current flowing into the minus side. Now, when you do that, Ohm's law says not V equals IR anymore.
Yeah, negative IR.
Yeah, when you have active sign, V equals minus IR. So if you're gonna use yeah, so it's minus I2, right? And you can actually draw that explicitly because it's kind of confusing, right? It's very confusing, right? This is one of those things, and I did this on purpose just to kind of throw you, right? So it's, V2, or you can just say, so V2 right here, right? This is active sign.
Or could you just say that's a negative V2?
Well, you did say it's a negative V2 here, but the thing is you got V2 wrong, because you said V2 was 2I, but V2 is not 2I, right? Because this is active sign. Is there another color marker? This is one of the most important things. It just comes up over and over again until you get this. You know, this thing here is telling you something important. So it's different than it is for this one, right? This is here, the I is going into the plus side. Screw that up, right? And in this case, this is passive sign convention, right? This is why this comes up. I really emphasized this last week. Passive sign convention has in addition to power, it also matters for Ohm's law, right? So like P equals plus IV and V equals plus IR in passive sign convention. But when you have it flipped, and they sometimes do this to you, they purposely kind of throw this to you by flipping the signs on these things. This is active sign convention. And so what we have here is that because of this, the power is going to equal minus I times V, and V2 is going to equal minus I times R. Both of those things apply. So therefore, V2 in this case is going to equal minus 2 times I. And therefore, it's going to be minus 2I. Yes. I have to do this every year. Let me just take this call. It is so weird. I'm going to pause this for a second.
Matt, this is not what we did. Yep, just kidding.
Hello? Hello? Who did? Who did? Who did? Who did? Why don't you call the office? They're there today. Just Google it. Well, actually, I just pulled it, but I'm in touch with it. Yeah, it's 831. You got it? 831. 6. Yeah, just sorry, what? Got it. No class. It's just right stuff. It's 831. Okay, 31625 2665. Yep. Yep. Okay. Yep. Bye bye. Oops. I guess I was recording all that. I wanted to stop it. I just stopped the sharing. Oh well. Anyway, it'd be an interesting recording when people watch that. Okay, so you got 2.5 done. Did you guys get 2.5 done? You did all that thing that I was talking about? Worked out okay, right?
Yeah.
Cool.
Yeah. And that means it's not.
Yep, that's the whole crunch of it right there. Minus 2 times I. Thank you.
But so that means this is what we follow. So what is negative IR? But I guess because we also hit the negative terminal first when we do the voltage law.
Yeah, so it's minus V2 when you do
Yeah, this is
with the voltages.
minus.
But it seems like you're going by that, and like every time you get a negative sign on a resistor. And yeah, this one, then you go
Yeah, the bottom resistor, you've got the minus sign where the current is entering. So
The other one
that
is
flips it.
You're not going.
You could also, to make it a little bit easier, you could write like V3 underneath the 2 ohm resistor and just put the plus signs the way you would prefer them. V3 is the opposite of V2.
Oh,
If you want, because they're asking you to find V2, right?
yeah.
But
So this is, when we have current going this way, this is active sign convention, right?
now when current's going to the right, that would be passive sign convention.
But it's going through the lower potential first, right?
Well, you just said if the current's going to the right.
Well, I mean, in this,
In this
this
circumstance, the current's flowing to the left, right?
yeah,
And so the current is flowing into the minus sign, so that's active sign convention.
Right.
So V2 equals minus 2 times I.
right.
So where does the
But
second?
then
So you have an arrow up there above it. When you say V2, it should say minus I2.
So where's
Minus
the?
I.
the
You're calling that I1 and I2? Yeah. And I1 equals I2.
Yeah, I thought they were different, but I guess.
Where does the second negative sign come from?
The fact that when you do KVL, because they didn't do KVL first with the voltages, but it's going to be minus 10 plus V1, right? Because you're hitting the plus sign for V1 first. Minus 8, right? And then you're going to have minus V2.
Oh.
Right? But what is V2, as we saw, because of active sign convention, V2 equals minus I times 2. So it's going to be minus, minus.
So when will you come across a resistor that in the equation that'll be minus I?
Sorry?
Well, like it seems like.
Yeah, ask that question again.
Yeah, I made the same mistake.
Yeah, this is a mistake everybody makes. And it's good that we got this out now, so hopefully everybody clears that up. If you think about it, if you didn't have V1 and V2 labeled and you just wrote I, you wouldn't have this problem. Because you would actually have labeled the voltage with the plus on the right side of the 2 ohm resistor and the minus on the left side. You would have labeled it passive sign convention. But they asked for V2 using that particular orientation. That's what they wanted to know. Right. So with that orientation, it's an active sign. I wish I could make it clear,
Everyone
but
done 2.6 yet?
people, is this 2.6?
Yes.
Yeah. Did you guys finish?
Yes.
Did it work?
I think
They're doing the same thing on 2.6 with VO, right? Because when you propose an I, it's going to be going in the opposite direction. It's going to be going active sign for VO as well. So the same issue applies. But yeah, and that's a dependent voltage source where it's determining that also depends on Vx, and your KVL says minus 35, and then plus Vx or just 10I, plus 2Vx, and we just said Vx is 10I, so 2 times 10I, minus 5I. Yep. Or, again, if you're not worrying about VO, like if you didn't even know VO was there, you would have just said, well, that's just plus 5I, right? So it's,
I don't know if it's called a K.
it's really,
Basically, we have 6 amps. Call this I.
once you get
That's confusing.
the idea that these are
call
sort
this
of
capital
separated,
I,
then you
and
focus on the
then
important
that
thing.
must be equal to
And
the
it's going to
sum of
always be
these three
the direction of the
I
current
plus I naught over 4 plus
relative
I1.
to the resistance.
Two equations.
What you were saying is, even if we didn't have this, we knew that this
Awesome.
was bye, but how would we have known that it was going to be negative?
Yeah, well, then when you look at this again, when you solve for your I and you solve that your I is 1 amp and you got 1 amp going that way, then it's 5 volts going from here plus, it's dropping 5 volts, right, across that resistor. So it's higher here and lower there. That means this has to be flipped because this is telling you you're doing it in the opposite way.
Oh, okay, so we only get the negative side if it's strictly.
Because it's active sign, you have to put the negative there. Yeah.
And when it's active sign, it will specifically say that the signs are flips. will we ever have one where the signs, where we have to assume that it's a active sign?
Will you ever have one where you have to assume it's an active sign?
Yeah.
What do you mean by that?
Let's say, for example, this was given to us and we
I
were
want
just
to
to
do-
assume that that was active.
Well, see, if they didn't ask for what VO is, you wouldn't have that problem, right? You would have just solved for I, and then VX is just 10I, right?
Okay.
It's because they asked for VO, and they deviously switched the polarity there, just to screw you guys up, right? Then you had to realize, oh yeah, that's active sign, so VO equals minus 5.
Okay.
Yeah.
Perfect. Thank you very much.
Yeah.
It'll work out.
Yeah. Okay. I think I'm gonna have to give more problems. You guys are working through them pretty fast. I can pull up the once you finish 8. I can pull up the. You guys are doing 8 already. Did you guys do all the other ones too? Or are you just working on 8? Did you do the other ones yet?
No, I thought we were supposed to just pick one.
Yeah, that's good.
Okay.
But then you can do the other ones too, because there's a good learning in all of them.
Should we convert this to like a pi thing or no?
That is a good question, and
Is either that or do we use a voltage divider equation?
well, yeah, I think you can just do the KVL for loop 1 and loop 2. You only need 2 loops to solve that. But
Because loop 1, loop 2, and the same thing as loop 1.
well, actually, you can do 2 KVLs, right? This one, and then you can do a KCL here, right? And
then
that
you
will
get
have
3
3 equations and 3 unknowns. Yeah. If you did turn that into a delta, would that help you? I don't think that would help you. It would probably make it worse. Yeah, don't turn it into a delta. That would make it worse. Because think about it, right? And
What about a pi then?
anyone got a marker? Well, pi is the same as a delta.
Oh.
But if you think about how that would actually look, right? You're taking this circuit, and oh, this is a terrible marker. Why don't you throw that one away? So, you know, this T would become a triangle. So would that help you? Let's see.
What is this?
Does that look any easier? It looks harder to me. So I wouldn't do that. But you know, this is really just you're just playing with you know, KVL and KCL and Ohm's law, and that's you can do a lot with that. You're going to get 3 equations with 3 unknowns, which is a little challenging. But set up a
I
matrix.
already did the linear algebra for the 3 equations, 3 unknowns, if anyone wants the answers.
And it wasn't that hard, right?
No.
Yeah, so you set up the equations, and then you can use free math if you want to. I can show you how to do that, or just solve it if you can. If you can, yeah. Yeah, so looking at your equation so far, you have minus 5 plus V1 plus V2, and V1 is 2I1, and V2 is 8I2. And then for KVL2, you have minus V2 plus V3 minus 3 equals 0. And V2 is 8I2, and V3 is 4I3, because you did passive sign for all these. Very good. So that looks good too. And then the last equation is this one, yeah, KCL. So I1 minus I2 minus I3 equals 0. Yep, and you set up those up itself. Doing a third KVL, it's not going to give you an independent equation. It's going to have the same inference. So you would have a determinant of 0 in the matrix, so you wouldn't be able to solve it. KCL is necessary for that last one.
So I have a question.
Yep.
On the homework, if we have those systems of equations, can we just say that we used FreeMat, or do we have to work the equations longhand?
No, I don't need to see you solving equations. So you can just use free math.
Okay. Okay.
But you should be able to, you know, on exams, I will test you and I will just check your equations. You know, I will actually ask you to put it in matrix form.
Yeah, for
Yeah.
one of the problems you had to do a 4 equations, 4 unknowns, and I did it
Yeah.
longhand.
Yeah, I wouldn't do that longhand.
Okay.
And if you on a test, you might have to do 2 by 2 kind of just concept on your own, without free mat or calculator.
Okay, awesome.
Or use a calculator, but you can't use a. Yeah. Anyway.
Awesome. Thank you. That answered my question.
Okay.
Okay, so if we did our KCL going this way, it would still be minus because we're going to be plus but against the current.
Okay. The question is on number 8.
Yeah, so for the lot number 2, we are doing the KBL starting from this point.
Mm-hmm.
But then the question is, what sign should I use for this one? Because the current is going
down. Yep.
Yeah.
Yeah, and that's passive sign convention.
Uh-huh.
And so
Okay.
V2 is just 8I2, but you're hitting a minus. So this V2 goes here, and you're hitting the minus first. So it's minus V2, or in other words, minus 8I2
Okay.
plus 4I3
Okay.
minus 3 equals 0.
Okay.
Yeah.
Yeah.
Good. Yeah. Thank you for asking.
Okay.
So yeah, so people who finished early are doing practice problem 2.10, and there was a question whether you need to do a Y delta, and the answer is not yet. You can collapse all those using just series and parallel, and you should always sort of try to just do simple series and parallel reductions before you pull out the Y delta, because that's much more complicated. Any other questions?
I put it like that because I don't know.
Like last time we were shouldn't it be positive before that?
The sign in front of which equation?
In this,
Yeah.
I put negative.
Yeah, because you're going clockwise through that right loop, and you're hitting the minus sign for V2.
In the last problem that the equation we plugged in was changed it into a positive, like the 2 negative.
Well, that was because it was active sign. This is passive sign.
Well, where'd you get 3 equations from? Oh, you like plugged them all in? Yo.
Why? What'd you do?
I just did 2. Well, I solved for I2 and I3 and then back calculate to solve for I1.
I mean, you substituted?
Yeah, I subbed it in from the KCL.
You substitute KCL, the I1 into I2 and I3? Yeah.
I feel like that's easier to deal with.
Well, I don't know. I'm kind of more inclined to just use the matrix, because when you do substitution, I've noticed a lot of people screw up all kinds of things when they do substitution. They make sign errors and everything. It seems like a more error-prone path than just leaving. And in fact, eventually, yeah, I recommend like doing the least amount of algebra possible to just get those equations. Have a lot of equations, and then just use free mat to solve them. When things
Now
get
we gotta
complicated.
solve it. But we already have a 1. Solve it, Isaac. So we can.
But you can just solve it using free mat. Yeah, or that.
Some bro swaps.
Yeah.
Is that 9?
Yeah.
Are these two in parallel, or does that mess it up?
The 9 and the 18?
Yeah.
Well, if you can attach, I mean, if they're connecting the same 2 nodes, they're in parallel. Are they the same 2 nodes? Yeah, because you can see there's like a node C right at the point where they come together.
Yeah.
I'm point over here. Right
Alright.
there, that's like a node C. And node B is actually going all the way to the start of that 2 ohm resistor.
Okay.
So it includes the start of the 9 ohm resistor. So basically, the 18 and the 9 are connecting between nodes like B and C, where C is right there.
Okay. So that's okay. You can do those in parallel.
Yeah,
Because
you can do
there's
it in
nothing
parallel.
in between them.
Yeah,
there's
there's
no-
nothing that would interrupt that. Yeah, they're both, well, because they're both connecting between the same 2 nodes.
Right. Okay.
Mark, I see you showing something. Hold on a
Yeah,
second.
I rewrote that to make it look more readable. So instead of, I separated the 3 out to make them look more parallel.
Yeah, and you can see what Mark did. he redrew it so it's more like a normal circuit.
Right. Yeah.
And that's another thing you can do. You can always redraw the circuit in a way that makes it more reasonable to solve.
Right. As long as you don't mess it.
Yeah. Yeah.
As
So
long
notice-
as everything's connecting to the same nodes, it still works.
Which was, that point where it has 1, 2, 3, 6 wires coming together. He opened it up and spread them apart, right? There's still 6 components coming together. This is still one node, but he basically spread it apart.
Yeah, that's a good call.
And then you can see the series and parallel a lot easier.
Yeah. Yeah, those diagonals are tricky.
Yeah, that's the topological kind of approach to kind of reducing things.
You can't, wait, so is this after he got rid of that 20 ohm? Because how can you redraw that?
Can you show that again, Mark?
Oops, sorry.
No, it's up there. There's a 20 right there.
No, at the top, but the one that going diagonal. How can you? Oh, you scooted the 2 ohm over.
Yeah, he scooted the 2 ohm over.
Oh, interesting.
It's a good exercise to try that.
Yeah.
Just
Okay.
being able to do that can really help your.
Totally.
Yeah. Thanks, Mark.
Did that help?
Yeah,
Awesome.
and it should be on the recording too. Somehow, did you turn off your camera? Because I lost your image.
Off the video.
You don't need to have it on. Just,
I don't? Okay.
yeah. Did it work out?
Yeah.
You guys see that one too? You did all that. That's the same one over there you're doing, right?
Yes.
Yeah, good. Cool. Want another one?
Sure. So do 10 or 2.
Number 11 is interesting because you have a kind of a short in between those. So yeah, you can try to figure out how to handle that.
You happen to have the answer for number 10?
Yeah, I think it's up there. I think it was 11 ohms. Yeah, you got it? Good.
I don't know if doing this manually is.
No, I would use a free mat. Just use free mat.
I'm using. No, I believe in Isaac.
Yeah, plug it in.
You believe in Isaac? He's good at. Is that his superpower?
No.
That's how the
He likes matrices.
the human versus the technological.
Even
Yeah.
the
race.
It's like a weird, stupid puzzle.
Yeah.
Are you guys trying to solve that thing too?
Like we have the matrix, but
Do you have a calculator that solves
yeah.
system equations? Is it not giving you the right answer?
No, it will give us the right answer. I just haven't done it yet.
Okay.
But I was just trying to do it.
Using substitution or yeah, that's really tedious.
I
Yeah,
have,
you can waste a lot of time doing that.
Yeah.
I would because the meat of this is the actual setting up the equations and understanding the concepts, how to interpret the results. So the thing about conductances is that when you have 2 conductances in series, you got to use the parallel formula.
Yeah.
Wait, did you solve it already? Oh.
So moving on, some folks are doing number 12, which is
I believe in you. I
That's what they want me to do.
do it.
finding V1 and V2, calculating I1 and I2, and the power dissipating in 12 and 40 ohms. This is a good one because you have to actually, I mean, you can simplify this thing with series and parallel.
Multiply -1.
Right. I mean, with just the parallel, I mean, you could, I mean, what I would do, well, actually, why don't you think about it for a second, and then I'll tell you what I think you should do.
Yeah, because you could do -ρ3 plus ρ2 plus ρ1. Well, yeah, but like we just write separately. Oh, yeah. If you want to be extra.
No, dude, I'm just gonna give up. You're solving.
Yeah, we did set up the equation. That works.
Good. All
We
right.
did MATLAB.
I'm proud of you.
That's all I wanted to hear. Yeah. Yeah,
Oh, you missed most of the session today.
let's take a picture of this.
You just walk in? I didn't see you all day.
Yeah, I was looking for my financial check. It's like, it's been like 2 weeks I haven't get it.
Okay.
It's supposed to pay out to my.
Yeah, that's annoying. Well, you can watch the video
Yeah.
afterwards.
Yeah.
So this one, you would definitely want to read the example problem 212 because I think it would actually show you how to solve it in a way that would be a lot easier than just going straight to KCL, KVL. Because if you do that, you could have 4 currents in there, which would be cumbersome to deal with. But you can simplify it a lot. And basically, I can show you. I'm sure what they would actually tell you to do is if you combine the 6 and the 12 resistor, you're still going to have V1 across the combined resistor. And you do the same thing to the 10 and the 40. Then you just have 2 resistors you can use the voltage divider formula for and find V1 and V2 using the voltage divider formula. And then once you find V1 and V2, you know what I1 and I2 using Ohm's law. Yeah. So it's really simple that way. And that shows you how these things can actually help.
Oh, that's the smart way.
Say this is also equal to, so I0 equals I2. I4 plus I2.
You guys want a hint? It's a different way of.
It's easier than doing this?
Yeah, you're going a roundabout way. Would you like to know a more efficient way?
Yes.
Okay, because this is the way you might think of doing. Because you got all these resistors, you might want to have a separate current through it. Now you could do it this way, and you could get the answer. And I don't want to stop you. It's educational to do it that way. But I'm pretty sure if you read example problem 212, the one that comes right before that, it'll show you how to solve this in a quicker way. And the method is, you see these 2 resistors in parallel.
Oh, yeah.
You can combine those, and they still have V1 across them. And then you can combine those, and they still have V2 across them. Yeah, and then you just have 2 resistors in series across a voltage source. You can use the voltage divider formula to find V1 and V2.
Right.
That's a good one to try these voltage divider things.
Right.
And then once you have V1 and V2, then you can find I1 and I2 using Ohm's law.
Okay.
So it's just like a 3-step process. None of all these equations are going to have, which are going to be really hard to deal with.
Right.
Yeah. So that's what I recommend. So I'm gonna have to get going. I gotta run to another class, unfortunately.
All right, bye-bye.
Later, Mark.